Hello everyone, and welcome back to another GIS lecture video. And in this lecture video, I want to dig into this idea of the functions associated with fuzzy values, right? In the last video, we said that these functions serve the role of taking the raw data, which is basically any layer that we want to use for suitability, is fed into this function, and no matter what range it had originally, it maps it onto these fuzzy values, which all will have a range of 0 to 1. Now, we're going to be talking a lot about these functions. And again, these are mathematical functions. They take in an input and they spit out an output. In particular, they're going to rescale, right, from whatever range we had to 0 to 1. But in order to talk about these functions effectively, especially in the context of how it relates to suitability, rather than talking about equations and sort of the nitty-gritty math part, what we're going to do is we're going to talk about them in terms of graphs. And what I want to do in this video is really outline how we set these graphs up so that when we're making 3 or 4 or 5 of them to compare different parameters, you're going to kind of get a feel for what you're actually looking at so you can understand the differences and why they matter. So let's go ahead and just walk through a random example. Okay? So what we're going to do is we're going to start off by making ourselves a graph. Right? So we have our x and our y. Right? Our x is going to be our raw data value. Right? So this is going to be the value that we are bringing in to our suitability. Right? This could be the elevation in meters. This could be the amount of rain in inches. Right? It doesn't matter what this is. And that's the beauty of this fuzzy membership, is that we don't care what the raw data value is. All we know is that it has some minimum value and it has some maximum value, right? The lowest value in the raw data set and the highest value in the raw data set. And on the y-axis, right, these are going to be our fuzzy values. Right? And so our fuzzy values, we already said, always go from 0 to 1. Right? And what we talked about a minute ago was this idea that connecting our raw data values to our fuzzy values was this fuzzy membership function. Right? And so I'm just going to draw, right? In this case, I'm just drawing a line. Right? So this line, this is, right, graphically speaking, our fuzzy membership function. Right, this is our fuzzy membership function. Now, again, in reality, if we dig deep enough, there is a mathematical function that is describing this. There's an equation that's describing this graph here. We're not so much worried about the actual equation as much as we are the relationship that this line creates between our raw data value and our fuzzy value. So what do I mean by that? Well, what I mean by that is if we pick some raw data value, let's just say this is, inches of rain, and we have a minimum value of 0 and a maximum value of 10, right? So if we were to pick a value right about here, this would be about 3 inches, right? What we would do, and this is basic graph interpretation, right? Is we're going to say this value, raw data value of 3, fed into this fuzzy membership function, right? We're going to look where this value of 3 hits this fuzzy membership function, the line that represents this function. And we're going to take it over to the y-axis. And this would be about, this would be about 0.3, right? So with this fuzzy membership function, what we're doing is we have a value, a raw data value, of 3 being mapped onto a fuzzy value of 0.3, right? This relationship between raw data value and fuzzy value, this fuzzy membership function that describes this relationship, can be used graphically to see what the relationship is like between a raw data value and a fuzzy value. And we're going to be looking at these kinds of graphs where we have the raw data on the x and the fuzzy value on the y. We're going to be looking at these types of graphs over and over again because the shape of this function, right, the shape of this fuzzy membership function is going to determine how the raw data values are mapped to fuzzy values. And depending on the shape is going to determine when and why we might use one of the different types of fuzzy membership functions that we talked about. Okay? So what I really want you to get out of this is really understanding how we interpret these graphs in terms of the x-axis, the y-axis, and most importantly, this idea that we can look at, say 7 here, right? We can look at a raw data value, go up to where that x value hits the function, trace over to the y-axis, right, to get a fuzzy value, right? So in this case, we also say we have 7 maps to 0.5, right? And literally all I'm doing is just basic graph interpretation. Look at a value on the x-axis, figure out where it hits the function, figure out what the y would be, okay? And this is how we're going to communicate this idea of fuzzy membership functions. So hopefully this makes sense because you really have to understand this idea to be able to follow along with the different fuzzy membership functions. So as always, if you have any questions, please reach out. Thank you.